Hi, everyone, and welcome to another episode of Tech Unhinged, where technology meets human. Today, I'm thrilled to have with me Gabriel Flores, a veteran in facilities engineering and automation with 4 decades of experience across semiconductor fabs, data centers, research labs, and pharmaceutical facilities. Over the years, Gabe has worked on critical infrastructure projects for industry leaders like Intel, Google, and the Los Alamos National Laboratory, helping design and optimize some of the most technically demanding environments in the world. He's currently the Director of Technology Engineering at Excite Americas, where he oversees automation systems for mission critical operations. Gabe, welcome to the show.
Thank you, Rubia.
Well, we'll start off, with your journey and our first question, Gabe. You've had an incredible journey across some of the most high-tech environments in the world. How did you first get started in this field of facilities automation? What sparked your interest in it?
Well, as you went through my background, I've been in the business almost 40, a little over 40 years now, I think, and about 30 of those years in semiconductor. But when I look back, I said, yeah, how did I get started? I remember when I was a young teenager, my father was a HVAC technician, and he took me on the job one day. And this was, back in the 1960s. Took me to a project, and he was working on an air conditioning unit. And he opened it up, and I saw all these wires and relays and components. And I'm a teenager, and I didn't know much. I said, "Wow, look at that! It looks complicated. I want to learn how they do that. How do they do that? This thing looks like it does controls, and I'm a kid, so that interested me. I went to college. I got a degree in mechanical engineering, and back then they didn't have discipline in controls. Okay, nowadays they do. You can go to college and you get a degree in control systems, but back then they didn't. So because control systems were still on the mechanical side. I started. So I got through the mechanical engineering school, and during that time in the 80s is when I saw my first personal computer. Okay, and I says, "Wow, look at this! This is called a computer, and you could do things on this, and you could, do word processing mostly, and look things, and it was mainly that's what it used to be for, is word processing, some spreadsheets and things of that sort for a personal computer." So I said, "Oh, okay, this is kind of interesting." And then we used to use it for data entry into the mainframe computers. I went through college, got interested on the computing side more, than the mechanical engineering side. So when I got out of college, I started working for a controls company, a small controls company, and I started doing design work with on drafting paper. Okay, because everything was on paper. Okay, so pencil and paper, triangles and T-squares and the like. Okay, and so I started doing that. Then this application started coming out. This software, this stuff called AutoCAD. Okay, and then it's this AutoCAD, and you could draft things, and you can put it electronically on a computer. So I started doing that, and we had to convince our management this is going to be the future. This AutoCAD thing and this doing stuff on the computer is going to be the future. And so, I remember AutoCAD 1.0 loading operating system, DOS operating system with stacks of disks. And, so I started learning how to, about operating systems and putting it on, loading the system on the computer. And it took 30 minutes to an hour to load an operating system. Okay. And then it took a big stack of floppy disks to load AutoCAD. Okay. And it took, minutes and minutes to render a drawing on the computer. It took a lot of time, and and then it just started growing from there. And I remember working on building a graphics by pixel, pixel by pixel, building graphics for an automation system, and it was on an operating system called CPM 86. So and then you could see the microprocessor speed started getting faster and faster, and you needed that speed to do more graphics, more automation, more detail, and the speed. You didn't want to wait anymore, because I used to go get a cup of coffee to wait for the drawing to re-render, and to zoom in and zoom out. It took minutes and minutes and minutes, to go do that. So you had to go get a cup of coffee and come back and see if your drawing was zoomed in or zoomed out. Okay, and so you can see the evolution there. and all that was interesting me. I was a mechanical engineer, and I was learning, more about computing systems and how to apply it. And gosh, today there are smart devices, with microprocessors built in. You have the Internet of Things, artificial intelligence, and all that was just, this microprocessor, and here's I worked at Intel for a long time, and so
This is
there's
one of the first
yeah,
microprocessors.
that's a microprocessor. Okay, and with all the wires not attached. Okay, obviously
All
when they
right.
package them,
All right.
they attach it to the socket, where and then you load it, bring the socket into a computer, into a motherboard, and so forth. But
All
that's
right.
a microprocessor. So that's one iteration, and there's another one, a smaller one, and this is from the 1980s. Okay.
And you have it as your keychain.
That's my keychain. Yes, I still
Oh
have
my
it.
God.
I still have
Yeah.
it. Yeah. So, the evolution of automation and such, and people's journey, and how, how people interact, and start using it and become efficient using it. It takes time. It takes
Yeah.
years. It takes time for people to adjust. But,
Yeah.
that's
So
kind of my journey. Yeah.
I
So,
sort of believe, Gabes, that we can clearly say that you're living your childhood dream.
yes, I think so. I think I made it. I made it work, and I've been enjoying it ever since. Yes.
Yeah, yeah. And not many of us can sort of say that, but we have an example.
Yeah, I mean, from the very beginning, from automation, from microprocessor based automation, because I used to do, like, mechanical. They used to do automate stuff through hydraulics or through pneumatics. Then it became electronics, and then microprocessor based, automation,
Yeah,
and now it's not just microprocessor based, because a lot of even the AI nowadays is using risk based type processors. So they're not full blown CPUs, and they're able to do micro tasks. And the smaller risk processors, they take less power and energy to operate. So, which is a big deal nowadays. Is we're finding is that things are consuming a lot of power. So that's a
yeah.
big problem.
So, Gabe, that sort of brings me to my next question. Given your decades of experience, how has the meaning and role of semiconductor fabrication facilities evolved over the years?
Right, right. So back in the 80s, like I said, we did a lot of controls and automation using mechanical devices and electrical devices. You're performing logic using electrical circuits and relays, and of course, that's the whole deal with a semiconductor now, is the relays are are microscopics, right? They're a relay, a gate in a microprocessor, is you have to use a microscope to see the gate. That's how small they are. But back, when they started, you're using relay, and you're calling it relay logic. Okay, so that was the electrical side. Then you had mechanical mechanisms that did that. So that was some of the earlier control systems. And I remember doing a scrubbed exhaust system, on a semiconductor, was one of my first projects to automate it. And we installed, a programmable logic controller. Okay. And a programmable logic controller, it was just that. It performed logic, and it kind of replaced the relays. So you kind of replaced the electrical relay circuitry and logic of ones and zeros with a programmable logic controller. So that's kind of how it started. And then we started adding some monitoring, some analog devices that to be able to monitor equipment. And so it was used a lot for monitoring, but because a lot of the people, again, we're going back to that issue with people and learning. Oh, this electronic stuff, it was mysterious, and you would load logic in, and it would perform this stuff, but I don't trust it. The technicians and a lot of people, they didn't trust it, so they wanted backup systems. So we would design these automated systems, but they wanted something they could touch, turn a dial, move something. They still wanted that human interaction. Okay, and even today, I think I was reading is that some of the cars, one of the major car manufacturers still wants to have some ability to touch and turn things on a modern car, because humans still have a need, some desire to touch things. Okay.
Yeah.
So,
Yeah.
so I think there's some human nature there that you have to understand and try to compensate for is what people, how people react, how they work, how they envision, how they perform work, and how they see things, how they see the world, right? How do they view the world? And so that's a lot of part of automation. So getting back to the semiconductor, so we were building automation systems, the programmable logic controllers, and then we were putting in these extra control panels that were with some knobs and dials and gauges or whatever, just in case the operator had to manually control the process, because they just were says, hey, if I need to manually control this process, I need to be able to do this because I don't know if I fully trust this microprocessor based controller. Okay. But, so we kind of started looking at that. And then the facilities started getting more complicated. The processes started getting more and more complicated. They wanted us to build things faster. They wanted less, people, they need to fix things quickly because these facilities are getting huge. These semiconductor facilities are getting larger and larger and larger and larger and more complex and more complex. So, the human, you just can't operate it anymore manually. They're just at a point where just we started getting rid of anything that was manually because it just got in the way. Okay.
Mhm.
And we didn't need more complications with any kind of manual operation. So we had to do that. And they wanted to reduce labor, so it was time to market, get it done, can't have interruptions to production, but because these semiconductor facilities, they started getting really complex. They're nowadays, they're tens to $20 billion to build a semiconductor facility. Back when I started, in some of the earlier semiconductor facilities, we were only talking about $1 billion, maybe $2 billion to build a facility. Okay. Now we're talking tens of billions to build a semiconductor facility. And, so they started getting bigger and bigger and more complex. The semiconductor facility, they use dozens and dozens of specialty gases and chemicals. Some of these gases are quite exotic. They're quite exotic. Some are quite dangerous. They're quite flammable. They're toxic. And that they use in the process for etching and out these semiconductor wafers. The material science is getting more exotic, more complex. Okay, and we're seeing that that the technology just leaps and bounds changing to get faster, smaller, and using less electrical power and less energy, because like a semiconductor facility, they can use over 600 megawatts of power, over 600 megawatts.
Mhm.
Some of these data centers, they're like 30 megawatts for like they call a hall, for a data center hall, and they might have multiple halls on a data center campus. So, this huge amounts of electrical power, huge amounts of cooling. Okay, like a semiconductor, 150 to 200 tons of cooling, because just to cool down, because you're putting in all this electrical power, putting all this chemistries in, and there's a lot of energy that is used to produce these little
Yeah. Mhm.
microprocessors. Okay,
Yeah.
it's huge. The
But was this
water.
was this one of the processors that you sort of built yourself?
Yeah, that was I was in the facility. Was uh, the reason it's on my keychain, okay, is because
Yeah.
it didn't pass inspection. Okay, the yield,
All right.
it probably had a flaw, and it was probably a reject. You can't be losing revenue by you're not making money on keychains. Okay, and that's where the automation is. It has to be reliable. Because the cost to produce these things is enormous. Interruptions to production is very costly. It's in the millions of dollars per day. If there's downtime, because these facilities, they run 24/7. They do not shut them down. There's people working these things 24/7 all year round, and so the systems have to be automated such that you can afford to do things while everything keeps running. Right? You got to be able to make changes. So there's hot standby, programmable automation controllers. The SCADA systems are hot standby. So they want you to design our systems to be designed for 99.9% uptime. Okay, the mean time between failures of components that we use, we measure them in years. multiple years of the mean time between failure for a component. So the reliability, needs to be, it has to have really high reliability. They can't afford an interruption to production because it is very costly. Okay, these facilities are huge, and with thousands of people operating them, and all the instrumentation that goes into these things, thousands and thousands of IO points that go into operating these facilities and controls. So that's a semiconductor facility.
Yeah. So, Gabe, for our listeners who haven't been sort of, aware of this term, which we're going to be using a lot, semiconductor fabrication facilities, right? If you could sort of quickly, give me one, two liners where you could explain the direct connection of semiconductor fab facilities with where technology is today, right? If you could just sort of put it in simple terms by making a connection here.
Right. Well, since the invention of the semiconductor, it was to perform logic, right? And to assist humans, right, and making calculations quickly, okay, is speed and efficiently. So that they've been working on that, the 1940s and 50s and then the 60s, and you just see this desire to perform calculations. And then we started learning the humans started using the computer to just do simple word processing and then writing software that does things. Then the internet came along, right? I remember when the internet came along, that was fascinating. Is the internet. Wow. I remember I had people working here in my hometown, and we were building a facility in Europe, and we could send them a message, on the internet. Okay.
Yeah.
And we were able to send a message, and then they called it later on, they started calling it email. you know, and so then, that's then communications, right? So now it's not just calculations anymore, and it's not just for, controlling equipment. Now we're using it for communications, right? So now this communication started coming along, with the internet, people writing emails, sending a photograph, starting to watch, stuff on the internet, looking and reading. And then now, it just started, all the communication really started moving along, and people could see, because what people, really like is that, people are addicted to communications
Yeah.
and information, right? People, are addicted to communications. They're addicted to videos and interaction. Humans still have that strong desire for interaction. So we're using it now for, a lot of that is to process, just human communications. And the semiconductor, and that's all from, semiconductors. Okay, is processing information. It's still about, ones and zeros, until other kinds of communication comes along, and computing, like quantum computing and such, that comes along, that's still, a need. And so they're getting smaller. We looked at the microprocessor. Here's a larger one, right? Here's the one in the backside. The one in the middle is a little smaller, and they're getting smaller, right?
Yeah.
Because you want to be able to put that intelligence in everything that you can imagine. You want to put intelligence into it and make it intelligent. That device, people, wear watches or all these smart devices that you can start using now, because you can make them very small, and they're wanting to make them smaller and smaller and using less power. So again, it's the consumption of power is still an issue. Is how do we power these devices?
So we can sort of, you know, reduce the size, but we are not replacing these anytime soon.
No, I think not. I think, there's still thought is, it's still digital. Okay. There are people doing research on analog computing, because that's nature works that way. And you'll see some people doing experimentation, trying to mimic, how nature operates. How does an ant wander around and can carry, 100 times his weight, right? A little ant, and it can carry the rock. They're carrying a rock around, a little to them it's a huge boulder. We would think in relation to ourselves, it's like a human carrying this big huge boulder around, effort. Where did they get the energy to do that? Where did
Yeah.
they get the energy? Where did they get the intelligence? What level of intelligence are they using to do some of that work, and to do the things they do, whether it's an ant or a bee or some other animal, as you go up the chain there of intelligence of different animals, and they're using some form of reasoning and computing somehow. Okay.
Mhm.
So there's research in that area. I know maybe something will come along in years to come, is how do they do that? Because they're
Yeah.
using very little energy. They're
Yeah.
just using what's available, the sun or some other forms, heat from the earth or what have you, to provide energy to perform these tasks.
Yeah.
So I think that's still a mystery to us, is how that, they're able to do that. And maybe one of these days humans will figure it out.
Yeah. So I sort of believe that, in sci-fi cinema that, a lot of Gen Z or millennials consume these days, now they would show you the small chip, which could be just literally added to you, inside human body. So
Right. Oh,
are those
yes.
chips also the product of these semiconductor facilities?
Absolutely, absolutely. I thought about that. Is that, and thinking of would I allow that, to put, because what frustrates me today is the security. It just drives me nuts.
Yeah.
I have so many accounts and so many passwords, and they're changing, and some softwares you try to use a common key, and sometimes it works, sometimes it doesn't. It's just so frustrating.
Yeah.
And I go, gosh, would I embed something in me, that's that would recognize my security, that and authenticate me, somehow,
Yeah. Yeah.
and just so that I wouldn't have to put up that, that annoyance of all this security and passwords and accounts and things like that. And I'm going, God, it's available today. You can do that, but are humans ready to do that? I think a lot of people just say, no way, I'm not going to do that. And then there's going to be people like myself. I'm an early adopter type person, right? I'll try things, okay, because being an engineer, you kind of want to experiment and things where see how they go, and it's a learning process, and
Yep.
just like I say, it took decades to learn how to use a computer and become efficient, where the computer was actually making a real good tool, not just a toy or a curiosity. And yeah, no. I mean, today, nobody will leave their house without this computer,
Yeah. No,
right?
no, no way that's happening. Yeah.
People sleep
Yeah.
with it by their bed, under their pillow. It is a way of life. You can't do without it. And it's a great tool, but it's taken decades, where
Yeah.
people, it's like, oh, no, I don't use a computer. Oh, no, I don't want this and this and this. And that, to today, like I say, it's where you're sleeping with it under your pillow, okay,
Yeah.
because you can't do without it. But it's taken decades to get there. It's taken decades, to make the other advances. It just doesn't happen. Some things just doesn't happen overnight, especially when it takes human, adoption, to be able to change and do something different, like putting maybe something in your body,
Yeah.
like a
Yeah.
microchip. But people are putting pacemakers in there, and they're putting
Yeah.
in other devices in their bodies, to make you live longer and make you function better.
Before we delve further, Gabe's automating facilities as intricate as semiconductor fabs is definitely not easy, since how we discussed it at Let's. What are some of the biggest challenges you faced in deploying automation across critical infrastructure?
Right. And I kind of talked about, right. I was talking about early on, we were doing stuff on paper and you're putting in software using floppy disks, and you're convincing the management that this is going to be the future. This is how everybody's going to do things, and computer coming along. It's all about convincing other people, especially decision makers and people with money, right, that they're going to invest in this, whatever this new idea is, this new equipment, this new smart device, that, oh, I can automate this stuff where a human doesn't really touch it much anymore. And, oh, I don't know if I can do that, and so a lot of it is about making changes. And I talked about the expense and the complexity of a semiconductor facility. So change is tough for people to handle, especially people that are trying to produce consistent yields, right? Consistent results, predictive results, and consistent product yield, because their bottom line is they got to make money. So you're going to make a change that could upset this process, right? I'm making money today, so how are you going to save me money, more money? So they have, like in the semiconductor, a lot of the major manufacturers, and not just semiconductor, a lot of companies nowadays that are, because they're automating. It's not just semiconductor. So it's what they call their copy exact philosophy, right? So they might have this philosophy that, like, say you repeat, okay, so that you want to be exact, so that any kind of change, if I'm going to make that change, I got to make it to everything. Okay, so I can get consistent, predictive results. And so some of the challenges in making these changes is what they call, some of these, they call the white paper process. You have to write a white paper. Okay, I have to prove to somebody, a team, generally a council or a board or something like that, that this change that I'm proposing, it has a return on investment. Okay, it has a justification of why I want to do this. It has a return on investment. It has an implementation strategy as how am I going to go implement this in this complicated facility, and what are the potential risks to production. Nobody wants to hear that, but what's the potential of risk? What's the probability of failure? What is the probability of failure that I might have? And so I have to work all these details out. Okay, go present it to a board, and go collect some more data for me. I want more data. Show me some more data. Is why do I want to do this? And so and a lot of them turn on investments on some of these on industrial. It's got to be like less than a year. 2 years, 3 years. Yeah, they're not overly interested in 2-3 year paybacks. Because technology is already changing within 2-3 years. Technology is already changing. So it has to have a pretty quick payback. Okay, so whatever I'm doing for automation has to have a pretty good payback. I don't want any risk to production. I don't want any risk to production. So how are we going to prove this out? So now I need also too is I got to be able to implement this idea, and maybe on a pilot project. I have to have a pilot project, a test facility, and so where I can manipulate this process and test things out. Maybe create some failures or simulations that simulate particular failures and such. And that's hard to do. Where do I do that at? What facility? Who's going to give me a facility to try this out on? Okay. One thing that has happened over the last year to 2 years is the U.S. government, they established this National Center for Advancement of Semiconductors. Okay. They call it the natcast.org. And it is an effort to assist semiconductor manufacturers and companies develop new technologies so that they have a factory, and process they can try to test things out and simulate in a test environment that's not going to impact production. Okay. So that's something they're trying out. Some of these companies, there's semi.org is another organization called semi.org that helps you try things out and test things that in different parts, because the semiconductor supply chain is massive, from all these exotic chemicals, gases, and the material science, and all these things that these tools that they run in manufacturing are in the multi-millions of dollars each tool. And I have thousands of these tools in a factory. That's why they cost billions of dollars. So each of these tools, they're quite elaborate. So testing and such is difficult. So you have to go test this, collect data, and so that you can have a compelling argument and a white paper to that justifies this change. So that's I tell a lot of people I'm not that smart. Okay, I never thought myself I'm not very smart. I know a lot of people are a lot smarter than me, but you have to be persistent. You have to be persistent, and you got to be able to address concerns by your peers, that need to support you in making some kind of change. You gotta be able to close all their concerns, to their satisfaction that you've addressed them, regardless of how minuscule you might think they are, or that's not worth. Don't worry about that. Oh, it's not. That's not going to happen. Or oh, that's a silly question. That's a silly. You got to gain cooperation. And so a lot of it, a lot of your work in that is just really dealing with people and trying to get them to come along with you, and agree with and support you.
Yep.
That's a huge part of your job. It's a huge part of your job, regardless of what you're right or wrong, or because people have to do this because this is flawless. This is great technology. We ought to do it. It's not that easy. You're
Yeah,
always
yeah.
convincing people.
I was eventually going to come to the question where I was going to ask you, given that you've had both the wins and the rejections,
Yes.
with the white papers and the approval processes. So, given that you worked at large orgs like Google and Intel, so you must have learned a lot of key lessons while navigating through the approval process. So while you were living in that time, except persistence, what other things helped you sort of get through that and then eventually, climb up your career ladder?
Yeah. So, like I said, I'm kind of persistent sometimes, so I would come up with an idea, and, for automation, I says, oh gosh, I got to write a white paper. And, it's funny is that, in the industry, a lot of times that, if you want to discourage somebody, okay, maybe they're not, they don't want to support you on this, or they're giving you a hard, they want to make this change. Oh, I don't like this. Well, what, I think you need to write a white paper. And it's like telling somebody, I don't know it was like a real evil thing, oh no, 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 not the white paper. I won't do it.
All right.
And there's a lot of people just won't do it. And I think a lot of it is because it's intimidating. It's, I don't know if you ever watched the movie, the Wizard of Oz, right? And Dorothy goes to the Wizard of Oz, right? And the
Yeah.
the flames and the smoke, and it says, and they're shaking. Is like, oh my gosh, we got to go see the Wizard of Oz, and it's scary because you're going before a board of intelligent people. They're asking you tough questions, and not just technical questions, but a lot about implementation and risk to production, and a lot of them is about the people factor, right? Is how are you gonna implement this? How are you going to install it? How are you going to construct it? How are you going to do this? How are you going to do that? And it's very intimidating at times. So you have to, like I say, just work through those issues. You can't
Yeah.
take it personal. A lot of people, they take it personal. They don't want to be seen that they failed, right? And they don't like to be put on the spot. Okay, I don't have an answer for that, but I will get back to you. Some people have a hard time with that, and so it's a lot of so you end up dealing more with human dynamics. A lot of what you end up working with really is with human dynamics. And I remember in college, I had all my credits, and I thought I had all my credits together to graduate. And I go to my advisor or whatever, and says, I'm ready to graduate. And he says, oh no, no. He says, you're missing you're missing a social science. You're missing what do you mean? Well, I got, all these credits, and I took extra, into my further education. I got all these other stuff, but they're all technical, he says. And you don't have anything in the social sciences. You need to take something in the social sciences. We want you to be a well-rounded person. I didn't understand that as a 20-year-old. I didn't understand that, when I was in my 20s. I just didn't comprehend that,
Yeah.
until years later. And you realize that you spend a lot of your time just working with, and it doesn't matter what industry you're in. You're always working and with people and trying to either convince them, that to do something, or trying to get them to do something for you, to work with you and cooperate. Right. It's, trying to gain cooperation. So, a lot of the skills, it's not, is the engineering. It's really about gaining cooperation from people.
Yep.
Okay. and getting them to buy in to what you're doing and to agree to what you're doing and to support you. Okay,
Yeah.
supporting your idea, giving you money and funding. There's all these different aspects of support you need along the way to make something happen. Okay,
Hmm.
from the technician in the field, that's doing something with his hands and installing it for you, to the procurement people, to finance, to the management people that are going to give you support of labor, to go do something because I
Yeah.
need labor to do something. So it's all about, again, getting people to cooperate and support you, and buy into your idea.
I mean, one has got to know how to be people smart because ultimately the technology out there is making impacts and people are ultimately going to be using them, right?
Right.
So, since AI is all the talk in the technology
Yeah.
world right
Yeah.
now,
Yeah.
we see its visible intersection with automation in very interesting ways. So while your focus has been on infrastructure rather than the manufacturing execution system side, have
Right.
you observed any use of AI or advanced analytics enhancing how the facilities are monitored or managed in today's time?
Well, it's interesting is artificial intelligence, right? AI, artificial intelligence. Well, a lot of automation is artificial intelligence, right? We're using, these microprocessor based controllers to perform tasks for humans, right? So we've been kind of in the automation industry, at least in the automation industry, we've been working with a form of artificial intelligence for, many, many years. Um, but one of the things that what we're seeing with the modern day artificial intelligence is the different ability to reason. Okay, and it's and to form. In some cases, it can be considered opinions, but it's reasoning. And it's collecting a lot of data, right? So over the years, we got all these control systems, but one of the issues that they've always had trouble with is dealing with so much data in these huge facilities, right? $20 billion facility with thousands of IO devices out there. All that data is coming in, right? And I can get, on my computer systems, I can look at a trend log, every millisecond or every second, every 5 seconds, every 15 minutes, every hour, and plot it out, over time and look at all this data. Boy, it is a lot of work to try to analyze that data. Okay. It's just so much data, and that's where the term big data came from. Well, okay, I got all these devices and I got all this data, but it's information overload. It's information overload. So then you ended up with information overload where technicians started to ignore things, and so why did you ignore this alarm? Oh, my pager or or my phone is just going off. It just beep, 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 and they just can't. It's just information overload. So there's been programs to try to reduce alarms, to classify them to what's important, what's not important. Well, how do you figure that out? How does a human, after a while, make that determination? Okay, as a technician now, is that I didn't design the system. I was trained to do a particular task, but I don't know how this all works and is all put together. Okay,
Mhm.
well, that's where I can see some artificial intelligence, where I don't want to go through some sequence of operation document and read and read and read and read. I'm out in the field. I just need to know what I need to do to fix this thing. Okay,
Hmm.
that's where, like, maybe an AI assistant can read through the data. According to the trend logs of all this data, it looks like you have an upset every night at 1 o'clock in the morning, or something along that line. And based on the sequence of operation, these are your possible solutions. Okay, that it could be the possible errors that might be in the system. Okay, well, that might give me an idea of where to go look. All right, because again, we want to do this. Management wants it done now. They want it fixed now. Okay. When it's not fixed now, the next day is, why aren't you done? Why aren't you done? What help do you need? You just tell me. I'll give you help. I don't know what else help you can give me, because putting more people on the job, humans, just going to get in the way, or, I need to analyze, and I need time just to focus on this problem. And that's, I think that's where, an assistant, I can see where, they can analyze lots of data and try to assemble that and consolidate it into something that I can go and narrow it down and go look at without having to go through reading, sequence of operations, operating manuals for a piece of equipment, and then all this IO that's coming into the system from the automation, all this data that I have to go put graphs together and stuff like that to try to analyze it.
Hmm.
That's where, artificial intelligence will be good at it. Is those repetitive tasks that take a lot of data in. Well, that's good at, artificial intelligence is good at analyzing data like that. I see that happening. So we start developing, these AI, bots and co-pilots, whatever, to help us, review logic, review, code issues, or review, where I don't know if you've ever read a code book, the NFPA, or, the code books, the International Building Code or what have you. Oh my gosh, to go find something is a huge amount of time just reading and reading and reading, and jumps reference to this, reference to that, and then, and then you still have to use judgment, to put all these pieces together to come up with a judgment, an engineering judgment, and they already have some of that's coming along. It is coming along is to providing assistance, and those are artificial intelligence systems that are collecting, on a subject that can try to assemble and shorten down this information into a smaller, something that I can, as a human, easily, absorb faster, so without
Yeah,
having to
yeah,
go dig for all this kind of stuff. So, there's certainly opportunity to do that. And that'll, I think, make us, move faster. And then again, it's just our technology curve is just getting, going to get faster and faster to make changes, because we'll be able to get data and analyze data faster, right?
yeah.
And so I think it will just accelerate things, how fast
Yeah,
humans
so
can get things
James,
done.
you sort of referred that how, these things could probably happen, given the idea of automation. Do you believe that they're not currently happening within those facilities?
No, I don't think so. And again, is when I was talking about the change, right? Is challenges. It's a change, right? So somebody has to, to build these co-pilots and teach them, right? You have to teach an AI, artificial assistant, right? Intelligent assistant. You got to teach it something, right?
Yeah.
And so where is it going to get the data from? So somebody has to, there's a lot of labor in collecting what you're going to teach this assistant, right? Where
Mhm.
is it going to get? Where's its source of information? Is your source of information in the right format that it can dissolve and understand? Some of this information hasn't been digitized in a digital format, maybe, so there's a lot of work just to teach an assistant. It just doesn't happen. I have all this data, even electronically, data that's collected over a SCADA system, supervising control and data acquisition system. Again, can I give that data to an assistant? Does it have the security to grab this data? How do I
Yeah.
manage security? Because I just don't want any, artificial intelligent device collecting and seeing my data, because some of that's proprietary. Some of that's
Yeah.
proprietary. I can't just be giving that data out. So there's a lot of complications. Yes, it can do that, but it's that implementation, the risk reduction. Like say, risk to proprietary data. That you don't want to share. You don't want to share that information with your competitors.
Yeah. Yeah.
So um, there's those type of complications. So it's and all this has to be solved before somebody says, okay, just turn an AI assistant, a co-pilot loose on my facility. No. Gets back to that white paper thing. You got to prove to me that all these things is, it's safe, that it's going to be I'm going to get a return on investment. How much is it going to cost me? Is my production cycle, because there's production cycles for every company, whether it's semiconductor or what have you. They're producing something, and then at some point you got to stop reinventing the wheel and trying to improve it. It may not be
Mhm.
100%. I got to make money on this thing. I got to get it out the door. I got to sell it, because if I
Mhm.
don't start selling it today, my competitor is going to start selling his,
Yeah.
and I got to get to the market first. I got to get to the market first. So, those are significant challenges, to you got to move fast. It might be a good idea, but maybe not, but not today. Might have to wait till the next production cycle, before we
Hmm.
can maybe implement something. Yeah.
Well, see, Gabe, that sort of makes me, more curious, given that how we see the advancement of AI on the daily basis, right?
Right. Right.
um, listening you, it still feels like that the big orgs, who are the stakeholders or at the core of making these semiconductors, they are still having a hard time juggling their tasks or the employee labor work to something that we call artificial intelligence today. It might be at the core of it in the old school way, but the new wave has yet to come, just like as you mentioned, probably, in the next production, that could entirely be
Right.
a new era for that matter.
Right.
So what I'm trying to understand is that, is it still just an idea for them rather than something that they should actually start using within their work, and it's still going to take them time?
Yes, because I think like you said, is it's kind of a buzzword today, and a lot of management people are wanting they realize they got to do something, and I think people have learned that you got to adopt technology, right? I think we've learned that, and and then some of this stuff it sells. Buzzwords they do sell. They have market value, right? And so it becomes a brand after a while, right? And brands sell. They know they need to do that, but I think right now we're seeing that it's finding the use cases, right? In theory it sounds cool, but like I said earlier, is that what level of effort is it going to take to implement it, and am I going to get a return on investment? So that's the bottom line, and I think so. We're still struggling with that, and of course, I would like to buy something off the shelf. I don't want to be the guinea pig. I don't want to,
Yeah.
to go through all the growing pains and the implementation pains and everything else, and then I pay for that. I would rather have somebody else pay for that, and then I just adopt it,
Yeah.
and just use it.
Yeah.
I think people would like that more than being the person that's having to figure it all out.
Given, Gabes, that you have been at the core of when the semiconductors were taking place, or when the technology and computers were taking their place in the world. So given that you've seen every phase through and through, and you've been at the core of it, does the next evolution in the technology excite you, or does it scare you?
No, it doesn't. I'm an engineer. Yeah, change excites me. I like change.
Yeah.
I wish,
Yeah.
I just wish it just doesn't happen fast enough for me. So I do like change, and yes, I am excited about that. And, I am concerned about a lot of times with change that, it's the people factor, right? Is what people are willing to adopt, or not want to adopt, and how are they going to use it? Okay.
Yeah.
And how are they going to use it? And because there's a lot of, we talk about all the good things, that can come out of it. But again, just like, this tool right here, it's a really good thing, but it
Yeah.
can be a really bad thing.
Absolutely.
All right.
Yeah.
We're struggling right now, with is that, there's the misuse of it, and
Yeah.
that is creating other social problems, so along with technology, I think there's going to be the human factor, that's the part maybe I'm more concerned about, is how our humans are going to adopt it. Okay.
Yeah.
And there's going to be we all think about the good things, and there's the people you can hear a lot about, the bad things, that it's going to take over, and you can't trust the AI because it can, be manipulated to making bad decisions or bad recommendations for you and this and that. Yeah, those all can be true. Again, those are, things that we're going to have to deal with, and to be able to manage, to qualify. I have to maintain my PE license, professional engineer, and I've got to, on a regular basis, on a regular cadence, I have to maintain my education level. I got to be continuously, either refreshing myself or learning new technology so that I am current in the world. Okay, and then that my judgment is maintain my judgment, my level of judgment, that I'm going to be qualified to make decisions on older things that I'm probably used to, but also on newer things that are coming along. I
Yeah.
got to be able to make a good engineering judgment. And and that's like recertification. So I see, where artificial intelligence, where the certification, that it needs, just like a human, that you probably have to recertify it on a regular basis. That AI assistant is giving consistent, and predictable answers that are based on good data. That is based on good data. Okay, that it's been what it's learning, where it's learning its information from. Okay, just like a human. Where you how are you teaching this thing? These are your kids. they learn from their adults, right? And they learn from what they see and hear and what have you. So that's where humans learn. That's how we learn. We can learn bad things. Humans
Yeah.
can learn really bad things.
So that is sort of exactly, where our conversation is headed now. Being humans, we are constantly worrisome about the impact of the value addition that we do within this world. So, you did touch upon the idea of certain dangerous gases, right? And a lot of energy or heat being consumed. So when we
Right.
talk about the idea of sustainability within semiconductor fab and data centers, so, how do you see automation in helping to reduce
Oh,
this particular energy consumption?
automation is all about making processes more efficient, taking a lot of the repetitive labor away from humans. And sustainability, like I was talking about, these dangerous gases. Well, what goes into like a semiconductor facility, what goes in has got to come out.
Yeah.
And it comes out in waste. It comes out in waste. It comes out in wastewater, or it goes out the stacks. And so whether it's going out the exhaust stacks or it's going out the water waste streams, they have to be treated. We just don't dump into the atmosphere these nasty chemicals and gases. They can't get them into the water supply. We don't want to be breathing on them. There's our neighbors, to the semiconductor facilities, the neighbors, they don't want to smell this stuff. They don't want to see
Yeah.
stuff coming out the stack. They don't want to see that. They're just like,
Yeah.
oh, I don't like that. Whatever's coming out of there, I don't like that. I bet you
Yeah.
that's bad for my health. Okay, the next concern is, God, we're going to build all these data centers for this AI energy they're going to use. The amount of
Yeah.
energy, whether it's electrical power, a semiconductor facility uses millions of gallons of water per day. Millions of gallons, not just a couple, millions of gallons of water. It's not just dirty water off the lake or the nearest river. No, this is clean, ultra clean, purified water. So clean,
Hmm.
that there's no particles in it. And, so again, what that goes in, it's got to come out, it's got to be treated. The automation systems, the more efficient they can do this, because, the treatment of these systems takes other chemicals. Okay. It's either other chemicals or energy, like some of the exhaust, treating is takes we use high heat, so we're using, say, natural gas or electrical power to really heat and burn these gases, these nasty chemicals, burn the heck out of them. So before they're released, they precipitate out of them other chemicals that got to be, disposed of. So the less energy or the less chemicals that we can use to treat these systems, okay, the better it is for the environment. It's less cost, to treat these systems, because it comes to the bottom line of production cost. All right. And, the impact on the environment and sustainability. Automation system, I mean, you just, you need, again, in order to treat something as a chemist, oh yeah, as a human, I can go take a sample of, maybe say it's water, wastewater, and I go and I analyze it and this and that. Oh, okay, well, just put a little more of that, or you can put a little bit of less, or maybe we're not putting it at the right amount of time, because
Yeah.
maybe the stream is not steady. Maybe it comes in floods, it comes in waves of water or what have you. So you don't want to, you need to be treating it at the right time in the
Yeah.
process, with the right amount of chemicals. So if I can reduce that, because my automation systems are evaluating, not only doing, simple PID, proportional integral derivative feedback control systems, but it's not just that. It's, some of that might be more predictive. And to be more predictive, you got to have data. And who's going to analyze the data? Somebody's got to
Yeah.
analyze the data. Okay. And then we're back again to analyzing data. And
Yeah.
that's where I think automation systems and even later, as artificial intelligence will come along and to help us be more predictive and preventive than
Yeah.
reactive controls automation. Yes, you can do reactive automation, but it's better for the environment, better for the money bottom line if you can be more predictive.
Gibbs, you also serve as a board member at the New Mexico Board of Licensure for Professional Engineers. which sort of puts you at the center of shaping engineering standards there. How does your role there influence the development of engineering standards, particularly, around critical infrastructure?
Right, right. Yeah. So the Board of Engineers. So our mission is basically to protect the public. Is protect the public, so that we have safe systems out there that are being built. People are talked about the recertification process, right? Making sure people are qualified to do this type of work, and that we have some kind of process to maintain their certification. Just like we're talking about artificial intelligence, I think that's going to happen. You need to maintain your level of proficiency. That is our mission. So not only with my board with the state of New Mexico, but I'm also, with the NCEES, which is a national organization in the U.S. So one of our responsibilities is to maintain consistency of how we're applying standards, requirements, for the engineering discipline across the U.S. And even with how people, in other, because it's a world economy as well now. So we're trying to understand is how do we deal with, engineering and products coming in and out of the country, because it's a world economy, so what are other countries doing to certify their professionals, adopt to their processes, or they adopt to ours, and understand, again, in a world economy. So we're dealing with that. And again, is we got to deal with the new technologies like artificial intelligence, right? Is that how is it being used in the profession of engineering? You don't want to just say, well, I designed something with you without really reviewing it, and it was all done by AI. Good to go. Okay. Again, I think that's where the human comes in, is that a human has this ability to analyze things. Sometimes you don't necessarily need all the data, but based on maybe my experience and how I view the world and how I understand how the world works, that maybe that response or that solution from AI is not, I don't agree with it. Okay. I think I want to check where it got its data from. So there's going to be times that, as a professional engineer, just like he does with any other software. I mean, we have software that perform calculations for us and such. And if it doesn't look right, they call it the smell test, right? There's also, people do that too. Is if it doesn't pass your smell test, then maybe you ought to take a second look at it. Those are the abilities that humans have, right? We have this intuition. We have these experiences, and we have this ability to talk to other people and socialize, and
Yeah.
maybe go ask the right person. I'm not really sure about this, but I think I know somebody that knows somebody, and we can probably, we can do that, and we need to be able to question data. Right. So a professional engineer, we still need that ability to question the data. Okay.
Yeah.
And if it
Yeah.
doesn't smell right, doesn't look right, then I think we need to go look and, and check, say, where AI is getting its answers from, or my other software that I'm using, because sometimes, as I say, garbage in, garbage out. Board of Engineering and the National Council of Engineering Surveyors is that is part of our responsibilities to help develop those standards and the expectations for engineers. Okay, their code of conduct, their ethics.
Yeah.
Is that's the other, is like ethics. Where does AI come in? With ethics,
Yeah.
because ethic is a very sensitive thing. Sometimes it's not real clear. Sometimes it's kind of gray. Yeah, it can be kind of gray. But ethics sometimes is based on people's either their religion, their belief, how they view the world. What might be ethical here may not be ethical somewhere else. That's something that humans, is that not necessarily we have to teach ourselves. Can you imagine
Yeah.
AI? How do you give rules to an AI assistant
Yeah.
when my rules or my basis may be different from yours?
Yep.
My view of the world and your view of the world is a little different, probably. And you might not see the same thing the same way I do. But I need to understand that. I probably need to educate myself. I
Yep.
need to probably educate myself. I mean, I'm lacking some education. So those are all issues that I think as professional engineers, and we all have to deal with and try to understand and try to make a better world.
Yeah. So, Gibbs, what advice would you give to, young engineers who are today entering this particular field, of engineering, both in terms of mindset and skills?
Yeah, well, you come out of the school as a young engineer and think you're going to change the world all at once. Okay.
Yeah.
So for some reason, you got to convince people. Because a
Yeah.
lot of times you may not have the money. Maybe some people do, but a lot of us don't have the money. So
Yeah.
you need funding, and you got to be patient. We talked about changing things, what it takes to make change. Because a lot of times, like say, you want to come in. Oh, I got ideas. I've got ideas, but it's convincing other people, collecting the data, being persistent, and using the tools, that are available and to you. And using all the tools, not just technical tools, but improving your skill set and your knowledge of people and social systems and social interaction. Because you need to understand is how people are going to use your automation, use your equipment. Sometimes you can't anticipate everything that what people might do. It may not be logical to you. It may not be logical. Again, as engineers, we want to make sure what we do is safe.
Yeah.
Right. So sometimes you have to study. You have to study what they do and how they perform their work. How do they drive? How do they see the world? And what do they look for? So a lot of times it's really social science too, is understanding that, not just as an engineer. It's just not just a technology. So I think getting into this business automation as it grows, I see it, changing and how is adapting to the people. So I think that's going to be something you need to focus on and improve your skills in those areas.
Yeah. So, Gabes, you've already talked about a lot of lessons, but was there like one hard learned lesson that has really stuck with you throughout your, professional journey?
A hard lesson was just writing white papers. I remember is failure. It's just, it's like, wow, I failed, and you're not used to failing as an intelligent person going to college, it's like getting an F, in school, fail,
Yeah.
big flat F, fail. I mean, that was hard for me to comprehend, that I failed at something. It's not it's not failure. It's a
Yeah.
learning experience. And after a while, you learn it's a learning experience. It's not failure. And as long as you think of it that way, then you'll continue to improve. Some of the people that that's the ones like say would use that. Oh, you got to write a white paper. Oh, I won't do it. Won't, because they're afraid of failure. They're afraid of
Yeah.
failure. So I think I learned how to fail. I'm pretty good at that now.
That definitely is a learning curve, and that sort of tells how, you've made it till here so far. But then, Gabe's, given that you've got a lot of experience, 4 decades of experience in the field engineering, right? There are software engineers and then there are field engineers. So do you believe that, software engineers get to have the more glam in comparison to the field engineers who are at the core of making things? And that
Well,
sort of,
yes, and yes, I do. It's obviously there's the, that's just the
it's like
nature of the
front end and
business.
back end, right? I
Oh
mean, back end,
yes, I
yeah,
know, but obviously, as you do learn after a while, is you can't get anything done. If we were talking about making change, right? You can't get anything done unless you have a field engineer that's going to implement it for you,
yeah,
right? You can have a really good idea, right? You
yeah,
can be really, really smart, but if you can't get the cooperation from the people that are going to implement this, they can make you look really bad. They can make you
yeah,
really, really bad. I used to tell people, I says, I can make a really fancy control system. I can make that system look really bad.
yeah,
And I can make this really dumb, control system, very archaic,
yeah,
I can make it look really good. So when I was a field engineer, I would say that I love the field. I like getting out there. I like talking to the people, understanding, again, their point of view, how they get things done. How do they like the design? What information are they lacking? What would
yeah,
make their job easier for them, move faster. So in order to figure that out, you got to go talk to the people. You got to go out there and you got to talk to people,
yeah,
and you got to be able to talk to them in a manner that they're willing to give you information. If you go out with a different attitude, some people just they don't want to give you information.
yeah,
Let them figure it out the hard way. Why should I help them? That type of attitude. You have to have the skills to go and talk to people to get information from them that's useful to you, and they're going to be willing to do that. And you have to have the skill to do that. Yeah.
what do you think the world would have been like had there been no semiconductor, fab facilities? Where would have we been today?
Ooh. Well, some people might say that would have been a good thing. you know, you wouldn't have to worry about your teenagers dealing with this, right? And the social media stuff and all the things that go along, the complications that go along with it. It just created all these new challenges for society. Those are the downsides. And then you have to look at the upside. It's like, oh my gosh, I remember it's like, trying to find a payphone. Did I have a dime or a quarter, depending on what year? It was in my pocket. And I used to carry it in your wallet to make sure you had a coin in your wallet to go make a phone call. Simple things, people would die, because they didn't have lacking communication or ability to call emergency. Or there's all
Yeah,
these
yeah,
pros and cons, but it's definitely not one-sided. There's a lot of complications and social issues that we got to deal with any kind of automation and future automation coming along. Whether it's going to be embedding stuff in us or having autonomous robots.
So Gibbs, from being a student to be able to work with big names like Intel and Google, for a larger time of your life, what was it like? What changed for you being, knowing that now you're making impact at probably a very large scale?
I talked about my humble beginnings, and I always wanted to know more. One of these things about these new companies that come along in their initial phases, they had money to spend. They had money to spend, and as an engineer, God, you need money to do things. You need money to experiment. They need money to work on cool things, right? And to have cool stuff. So that's how I got involved with those companies, is looking as a person outside, looking at what are they doing inside that building.
Yeah,
I really want to know what they're doing inside that building. Whatever it is, it's got to be cool.
yeah,
It's got to be cool. And as an engineer, I just wanted to know what are they doing inside that building, and I want to be a part of that. And I want to see, and maybe I'll like it, maybe I won't. I'm going to learn something, and that was my key goal. I wanted to learn something, and
yeah.
and like I say, maybe I'll like it, maybe I won't. I
So
want to
once you
learn.
were on the inside, what changed? Like how did you feel about it when you were a Googler or part of Intel
Oh
or
yeah, because
in America for that matter? Yeah,
yeah, like I grew up through, I was, gosh, I was with Intel for 25 years, and
yeah,
when I went to Google, and it's like, oh my gosh, man, I'm kind of old, It's like, I wonder if I'm going to be able to hang with these guys,
yeah,
all these the nooglers at Google, because they're used to dealing with all these different things. And I remember being on the Google bus going to work, and I'm on my computer, working, and because everybody's on their computer working in the bus, and oh gosh, I get to work and I'd be nauseated, sick in the bus because it's like a ship, it's moving like
yeah,
this, And I
yeah.
talked to this
Motion
one
sickness.
guy. He was just out of college or whatever, and he came in, from San Francisco on 45 minutes on the bus. And I go, gosh, I says, I asked him one day, I says, I get sick. By the time I get to work, man, I'm nauseated. I'm about to puke every day. He says, "Oh God!" So it's not just me. I said,
Yeah,
I
it was
just
it
thought,
was
maybe
good.
it was just me. He says no, and I realized too. It's like, my skills were pretty good. My technical skills were good. Obviously my personal skills and my social skills were good. It was more about, okay, what are we doing today and what it needs to get done, and how do they do things? What can I learn from this company? What are they doing, that I can learn that's new? And
Yeah,
because they were, they were the forefront. They were spending a lot of money. Google became part of our, vocabulary, is the search engine, and how did they do the search engine, and what were they, it's all about, automating the software and automating the search and how it did that, the algorithms, and what were they doing in business? How did they see the world changing, and
yeah.
how were they going to implement change in the world? Again, because, as I told you earlier, I like change.
Have you sort of had any interactions with Gen Z engineers?
Yes, well, I have kids and I have grandkids.
All
Okay,
right.
so I have kids that are in their late 30s. I might even be 40 by now. I'm not sure. I have to ask my wife. Down to in their late 20s, I think. My youngest, and then I've got grandkids that are 4 years old and 17-year-old, and I'm curious to see how are they using these tools, these social tools, again, this computer here,
Yeah,
and other forms of automation, because I love that. How do they interact with their cars? What's troublesome to them? If the car breaks down, how are they going to fix it? How do they deal with that? And I'm curious about my 4-year-old granddaughter, and I watch her playing with her tablet, what she knows and how she's being educated, not through just, my daughter educating her and the school system educate her, but their people are learning, being educated on their own, right? They're being educated through, through social media and what's online, right? And some of that is good, so a lot of it is good. So how is that going to affect their education and their view of the world later on? So I'm curious about that. I'd like to see how that goes, the good things and the complications that come with it.
Yeah. So can you just name any one innovation or trend for me in automation that you're sort of keeping a close eye on in the future, which will be the
Yeah,
next
yeah.
breakthrough?
I'm still I'm kind of disappointed. I'd like to see the networking. Right now, it's the digital communication. Okay,
Yeah.
whether it's, well, I guess maybe could be analog communication. Maybe that's the better, because analog communication, there's some real benefits with analog communication over digital. Some things that the radio signals and such, analog signals are really good at. It's that common level of communication we're still lacking for devices, intelligent devices, to seamlessly talk to each other, okay, without a lot of effort. We're still lacking in that area there, that we don't have a real solid common platform for intelligent devices. I really want to see that go somewhere. I think that communications, I'd like to see more use of microprocessors, whether is it really microprocessors, or is it going to be something else other than a
Hmm.
microprocessor?
Yeah.
I think I want to see, I'd like to see where that's going to go. This quantum computing thing, they're working on it. Is that going to change computing altogether? It gets back to that, is it going to be closer to mimicking nature? I think wireless as well is the other area. It's still communications. We're still
Yeah.
having trouble even with wired communications or fiber or what have you, but is wireless communications. There's great things, and there's a lot of improvement to be made there in wireless communications. I'd like to see where that goes. And then the other thing is energy. All these things require energy. And like we were talking about earlier about nature, how does it do it? How does an ant, carry boulders, huge boulders around? How are they converting that energy to
Yeah.
do that? And how do we, if we're making intelligent devices, IoT type devices and such, artificial intelligent devices, they all need power, some form of power, I would think. So I'd like to see, where that goes, power more efficiently, to power these automated devices, or else they'll just sit there. They're going to do much if they don't have power. If they can't communicate, they're pretty much useless.
That's true. So, Gabe, we've had a lot of discussion around, technology and semiconductors. So, other than engineering, what were some of the other hobbies or passions, that you had in life? Or was it just engineering?
No, and maybe that's another lessons learned for young engineers. You need to find a way to relax and to refresh. You have to refresh. The body needs to get refreshed. And you'll find that once you're refreshed, you're more energetic, and I think you can probably be more productive, come up with better ideas, be more enthusiastic, be more determined. All these things that takes energy. Again, it's back to the energy thing, right? Is you gotta, our body needs energy.
Yeah.
And I like to, garden. I like maintaining, my yard and my house. When something breaks in my house, I'm on it. Because it's relaxing me to go fix something. Do
Yeah.
something
Yeah.
with my hands, do something with my
Yeah.
eyes. Feel the weather, feel the cold, feel the heat, smell, explore. And when I do those things and when I go to work, I feel refreshed and I'm ready to take on the next challenge. You got to find a
Yeah.
way to refresh yourself.
Well, Gabes, I think that this conversation has been incredibly insightful. You've taken us behind the curtains of what it really takes to build and maintain some of the most complex systems in technology. Thank you for breaking it all down and sharing the lessons you've learned along the way. It's truly been a pleasure having you on the show. Thank you so much.
Sure. I was glad to share it, and hopefully somebody gets something out of it.